Assalamualaikum everyone, this is SYEDA ZOHA UROOJ and today we are starting new series of logic design and switching theory. This subject is also called as a digital logic design. The book I am following is A Digital Fundamentals by FLOYD and JAIN 8th edition. I am going to link a website in the description box from where you can download this book for free. I know you guys are aware with analog quantities and digital quantities, but just for a revision, I'll explain it again. So the analog quantities are having continuous values. It means you can have infinite values between two numbers. Let's take an example of number 1 and number 2. You can have infinite values between them like 1.1, 1.2, 1.3 and so on. Things that can be measured quantitatively are mostly in analog form. For example, air temperature changes over a continuous range of values. Let's take an example that you measured the temperature of the room and it's 35 degrees Celsius. After a few minutes, it wouldn't be like 40 degrees Celsius, but it would rise in decimals like 35.5 degrees Celsius, 0.4 and so on. Other examples include time, pressure, distance and sound. These are the examples of analog quantities. Now coming towards the digital quantity, that is the discrete set of values. The digital advantage. Okay, so you also have an advantage of digital quantities over analog quantities, that is they are very useful in electronic applications, can be processed, transmitted more efficiently and reliably, best for more storage, and music, if it's converted into digital form, it's stored more compactly and noise effect is less. So in digital electronic circuits, there are mostly two states. The high state, which is represented by number 1, and the low state, which is represented by number 0. And this is the positive logic which we'll be using throughout the lectures and is mostly used in the book. The examples are the open and closed switches and lamps turned on and off. In computers, these two states, which is the high state and the low state, is mostly called codes, and it is used to represent numbers, symbols, alphabetic characters and other information. So the two-state number system is called a binary system, and it consists of 0 and 1. And there is also a negative logic. In the negative logic, the positive logic is reversed. Now number 1 is representing the low state and number 0 is representing the high state. Well, the positive logic is the high represented by number 1 and the low represented by number 0, and this is the thing which you need to understand and remember. So a digital waveform is the series of pulses. Basically, it is the voltage levels that are varying between the high and low levels or states. So the examples are the positive going pulse and the negative going pulse. What is a positive going pulse? A positive going pulse is when voltage or current goes from low state to the high level and then back to the low level. Let's come towards this diagram. Okay, so see, at time t0, the state is low. Then the state rises to high and then comes back to the low state. This edge is called the leading edge. Why is it called the leading edge? Because it is coming first. And why is it called a rising edge? Because at this level, from low level, the level is rising to high. So this is called a rising edge or a leading edge, while this is called a falling edge or a trailing edge. Alright. Now come towards negative going pulse. from high level to low level and then back to high level. So basically it's the reverse or opposite of positive going pulse. So in this, you come from high level, the voltage or current comes from high level to low state and then back to high level. But you can see there is this little twist that this time the leading edge is called the falling edge, because this time don't remember it with this that leading edge will always be called as rising edge. No. Leading edge is the edge which is coming first, the edge which is coming first. And it is called falling because the condition over here is falling. And the condition over here is rising. Because from the low state, the level is raised to the high level. That is why it is called a rising or trailing edge. That's all for the introduction video. Topics that we will cover in the next video of digital logic design includes explanation of how digital waveform carries binary information, timing diagrams, and basic logic operations. If you like this video, give it a thumbs up, and also if you have any confusion, write it down in the comment section. I will try my utmost to help you out. Thank you.